Hello, good morning, everybody. Wait, let's do this one. There we go. Actually, no, let's do the big one. All right. Good morning, or wherever you are in the world. Lots of people are in lots of different places. We're back today with a different Veloren Reading Club. Actually, the sixth one, not really a different one. We're going to be approaching some interesting topics today, though. So last time we took a look at how we could start contributing to the Veloren project, and we looked into how we can be editing some config files and how we can be doing some other work to get our code integrated with the project. And so we learned a little bit of Git as well. But this week, we're going to focus a lot more on some of the internals. And I'm super excited for this because Git is a really amazing tool. And it gives you a lot of capabilities of doing stuff very high level. But there's also a lot that's going on under the hood. So we're going to explore some of that today. And then we're also going to take a look into some of the economic simulation behind Veloren. And so without further ado, I'm going to bring Christoph here onto stream. And Christoph, I will get your slides posted right there, and I'll let you get started.
Yeah, hello, welcome. I would like to introduce you to Git. Basically, Git is not that complicated once you actually get a better understanding of it, and I'm trying to give you some background here. So basically, Git is just about storing binary files by hash. So for example, let's build our own repository. We start adding two files, actually one file which contains some contents and some file which contains other content. And we just put it into the database, and this is actually the, there's my mouse. This is the hash which is generated for this file. So from now on, we can just access these files using the hash. And as you can see, if I just type git file, it will just give me the file associated with this 4F4115. So, but we are not only interested in contents of the files, but we are also interested in its position in the directory tree. So if we just introduce a special binary object, which is a tree, we can also store whole sets of files within there. Basically, it's a combination of permissions. The next one is then actually the type, which is tree or blob. Blob is binary large object. So basically a file, and a tree is a subtree. So basically more files within that subfolder. So I just took a look into the repository which I created, and there is actually two tree objects in there. One is a topmost. This is 9.8, and one is the folder. And as you can actually see, this sorry for clicking. This 1a, if I just use that as a reference to get the contents of that directory, it will just contain this other txt. And this other txt just refers to the file which I already stored in, which contains actually this other content. And within the topmost folder, this D6 file is just this other file which I added. So this will enable us to store files basically in a database. But if we really want to take a look into development, actually storing development, we also need some metadata stored within that database. So it not only stores files and directory trees, it can also store commits. And these are also accessed by hash. So if we just take a look at the contents of the BO19A, abbreviated, and basically it all has 40 letters. It will just give us that is 98DDA. This is the one I already showed. And I'm the author, and I'm also the committer. And the commit message is the last one. So this is basically the information which is stored for the commit named BO19. And then the next stage would actually be, we're not only committing once, but we are also committing multiple times. And then we actually get another element, which is this parent. So starting from here, we have a directed ancestry graph, which just gives us the whole history and all the files which are contained in there. And Git will just store all this. And this is basically all we have. But of course, we would like to actually talk about specific parts of the development. And this is why we assign names to the hashes. As you can see, actually within this repository, there is 3 different branches. One is called main, one is called main2, and one is called main3. And these actually point to different hashes. So we can also synchronize peer-to-peer, but actually the interesting part is Git only stores hashes to binary objects, which might be files or trees or commits. And it also stores some names to the commit hash. And this is all which is to Git. Of course, it comes with utility functions and peer-to-peer synchronization. And this peer-to-peer synchronization is very handy because you can actually do distributed development without any central server. So if I just exchange patches to Veloren with Angel, he might be able to actually send my patches to the central server. Yeah, actually to the server we agreed upon. There's no need for a central server, but it of course makes exchange more easy. And I would just later on continue development and then connect to the central server as well, and just push my changes. It would just be compatible with the changes Angel pushed via the other route. So it's really peer-to-peer. It's distributed. And this is the main reason why Git can never actually do some sort of version numbering. Because actually this decentralized storage just results in no central authority to actually give some version numbers to files. So
just before you go further, one thing I was sort of curious about is that we saw in some of the earlier examples you had on previous slides, this idea of like file permissions. And so I was curious, how does, so like here we can see 0600, and then I think in a few slides back, we could see like 100. So how does this get stored as part of the tree?
To be honest, I'm not sure whether it's actually stored binarily or whether it's stored in text form. My assumption would be that it's text form.
Mm-hmm.
And as far as I recall, actually, Git is not storing more than basically, let's say, 6 bits of data.
Really interesting.
No, actually, I see it may actually do more, but
because so I know for myself when I work on projects and then I forget to make like one script executable or something like that,
yep.
then I do the command to make it executable, and then I'm able to make a new commit with that. And then I think when it's on GitHub, it does show that there's like a file permission change, but I don't know exactly like how it would track that with so few bits. That's interesting.
Basically, that would be a different entry within the tree. So actually the entry within the tree would change. Whether it's actually the contents changing, that would be a different hash, or whether it's a permission changing, actually it's just a change within that directory tree, which gets synchronized the normal way. So you could either change the permissions or the contents or both. It doesn't matter make any difference. And since it's hierarchical, actually the system will only distribute the subdirectories which it changed.
Okay. Yeah. Interesting.
And of course, since this is, yeah, sorry, please continue.
Oh, no, sorry. I was going to say I didn't have anything else to add on to this. So I wanted to hand it back over to you, but you go.
And of course, since actually this is a sort of, it's a directed graph. So basically, starting from the newest commit, you have a history of commits. And for every commit, you actually have a connection to trees, maybe subtrees, and files. And of course, Git actually has to make sure that all of these referenced objects are within there. So whenever it's synchronizing between servers, it has to actually transmit all the parts which are missing from the whole history.
And if I'm not mistaken, each commit only has a link in one direction, right? So it's like
Yes.
the newest commit can reference the one before it, but that like previous commit can't reference the newest one.
Yes, it's a directed entity graph, a DAG.
Okay.
And this is also why it, well, actually, it should not contain any loops. Although if you actually are able to actually get an SHA-1 collision, you might be able to create a loop.
Interesting.
Because since it contains the history, actually without a collision, you would be unable to create a loop.
Yeah. Okay. And so it would have to be like a collision between hashes on that are like there's two of the same hash on the same tree.
Yeah. Otherwise, you would not be able to actually insert actually a node which is identical to a previous node
I see.
in hash.
Mm-hmm.
And it would probably confuse the hell out of Git if you actually
Yeah.
able to do so.
Yes. Things would break. Yes. All right. Yeah. So I think that was my question. So I'll hand it back over to you to continue on.
So actually, I'm quite fine with having questions. I also prepared just this test environment. Let's just take a look. Apart from just sharing actually this information about Git, I would also like to share more information about my favorite Git client, which is TortoiseGit, which is only available for Windows, sadly. But this one actually comes with a very intuitive interface. I've used it for years, and it's really the gold standard of user interfaces. So if I just take a look into this test folder which I created, and I just take a look into the log, unfortunately, I'm unable to zoom in. Here I can actually see an interesting, complicated history. So it just started from the first commit. Then I did an second commit. I just restarted from the first one, did a third commit. And there's a different history here. And I also did a fifth commit here. So what's actually interesting within Git is these association between names, which is what we are typically talking about using actually branch names, and hashes. This is just arbitrary. You can just move your association between names and hashes around however you like. So I could actually just rename all the branches, or could just shuffle the branches, and it would just confuse me. But of course, there is actually ways for the server to remain actually at a consistent history. So, and you can also see that I created 3 different remote repositories, actually, namely Origin, which is GitLab. There is GitHub, and there is also another, which is a local one, which is this Taste2. And all these repositories actually might have a different idea of what the main branch is currently. So within
one thing I might suggest is if we make this window small and then you change your screen share to just show this window. I just thought about this now.
Yeah, that makes sense to
that
me.
might work.
Just
so
check.
you'll just have to stop the screen share and
Yeah,
change it over.
share.
So I think what I was seeing from there, and I'll just kind of comment on this while you're setting that up, is so we have a few different commits. We're taking also a look at like what the different remotes look like. But I think what I'd be curious with, or what I haven't figured out yet by looking at it, is which remotes have like which of them are like up to date with the current commits, and then also I guess like there was like a little bit of a branch structure there, but I was curious. There's like a hop in one of the branches, and so we'll take a look at that too. Oh yeah, sorry. Let me. All right. Yes, I think yes. This should be good.
I can also just make it a bit smaller vertically, which should also increase
Oh,
text
this is
size.
perfect. Nice, nice.
Oh, yeah, that's much better. Okay, so yeah, so actually the green and the blue, the green and the red ones, these are local branches and tags. Actually, tags come up yellow, and these rose-colored, these are remote branches. And there is actually there is 3 different remotes. There's GitHub, GitLab, and my local test. And so if we just, for example, go here and push this one to GitHub, let's just see. Yeah, let's just push this one. Oh, close it. So now the rose-colored marker actually moved, and we can see that actually on the GitHub server, main2 is also identical to my main2. This is basically just publishing my changes.
Whereas we can see, for example, like test2, that remote is still at a previous commit.
Yep. And also the GitLab one is still here at the bottom. And I could just push that one to GitLab. Let's just do that. Yeah, that would be origin. So main2 is fine. And now you can see that on GitLab, main2 is also at this branch, at this commit, while the main is still at a different one. I can even just go to this one and push it. Let's just push here. Okay, yeah. I'm not allowed to push this one because it doesn't have any tag. Let's just create a tag. And I hope this will, yeah, push to, let's just use GitLab, and for the remote branch, we just take main2. And now I actually need to use some sort of force because I'm changing history on the server. Yeah, actually, I'm just changing the history of the branch on the server. And now my main2 just moved. So this is really just about actually having a name which points to a hash. And you can just move it around and arbitrarily change it.
And so it looks like here we have 3 separate branches. We have main, main2, and main3.
Yep.
And so each of these are effectively each of these branch names is just pointing to a commit, and then whether or not we've pushed this commit to a remote is separate from that.
Yes, that's totally independent.
So, for example, we can take a look at the main3, which is the 4th file right here, and we can see that right now it's currently not on any remote, right?
Yes. As this one, this add second, this is also not on any remote. We could just push this one, for example, to let's just take GitHub as well. And now this one is on GitHub, but not on GitLab. So it's really peer-to-peer, and it's really just exchange of information. And typically, for a normal push, especially when it comes to protected branches, which is a way for GitLab and GitHub to making sure that you're not actually changing the history in a very uncontrolled way. You can just move these branches around, and normally you just for a branch it only moves up. So if I just push this main2, this one, this one main2 to the GitLab, which is origin, let's just push this one, I don't need to force because it's just moving upwards. It's just adding more information to that one, but it's not destroying information.
But we would have to force push if we were considering something that might move down or like laterally.
Yes, exactly. This is what, and there is two different types of force push. One is actually the normal force, which is actually has no conditions. And there is the force with lease. And this is the one I typically prefer because this one will only actually force move a branch if both you and the server have the full history. So no one actually, this is really interesting if you are actually collaborating on a branch and another developer just committed to that branch. And now you actually did a rebase of that branch to a different entry, for example, to a newer master. And this rebase is, of course, destroying or changing history. And if you would force push that one, you would just destroy, or just the destroy is wrong. Actually, you would just hide the changes the other developer did because you just moved unconditionally the branch name to a different hash. And with the force with lease, it would just warn you that there is no new information on the server, which is not on your local copy. So you should actually download it, which is fetching, and take a look what's happened there.
And yeah, I just want to add in the little bit of foreshadowing where you describe the destruction of data and how that's not actually sort of what happens. And so yeah, I think we'll dive into that in a little bit, taking a look at what it means to actually why deleting history isn't actually the way it always happens.
Yep. So let's just move that red dot here to a different position. Just move it up there to actually just to be based on main2. So I just changed to that one. Now this one is active. And I just rebase it on this one. We just start rebase, which is an interactive. You can still actually combine or rearrange, or so basically change the order of commits. Now it's done. And as you can see, actually this add second, I just moved this one on top of this main2. This is a rebase. And this is most helpful if you just want to actually get your local changes combined with a newer version of the master branch, for example.
And so just to elaborate a little bit more on that. So we saw this a little bit visually where we had a commit that was on its own branch, but by taking it and rebasing it on top of the main branch, then we were able to say, I mean, to me, it makes sense. I want to add all of the changes. So I want to take all of my changes and apply them to master. But in this case, we can see very visually that the commit that we had, which was down near the bottom, now gets put up near the top, which implies that it's now in front of all the rest of the history.
And of course, you could also just start from here and rebase these 3 commits just onto this one. It's just as arbitrary. You can just move actually this independent, basically it's branches of history around. And of course, if you do so, you create a new hash. So actually this commit actually contains the same changes as this commit. It also contains the same author and date, but it has a different history. This is why any change in history will change the hash, and thus actually changing of history is another topic which is probably beyond this presentation. It can be done. It's always a pain, and of course it has to be done for all developers at once, because otherwise any developer which actually pushes to the server using old history will still commit the old history and actually still actually move all the files which you would actually have liked to erase, for example.
And so an example of this for Veloren was back when we started out the project, we would take all of the asset files and commit them directly into the tree. And then there was one point where we said, okay, well, we want to take out every binary file, every file that's not a text file, and we want to put it into Git LFS. And so we had to go through every single commit in history. And even if there was commits that didn't have any changes with these binary files, they still had to be rewritten because what they depended on would change as well.
Yeah, the hash of the parent would change, and this is why the hash of the commit itself would change. So basically, any change in history will give you a new hash. We can also just cherry pick, for example, this force file. If I just cherry pick that one, that should be a single file being added. Yeah, it just works fine. So now actually this one combines the force file as well. So if I just take a look into the directory, let's just take a look in here. Here you can actually see force, and within the folder there is actually the second, the third, and the fourth. So it's all the files combined actually within this specific commit. And right now this commit is not synchronized to any server. So let's just push this one to GitLab, for example. And now you can actually see that the rose-colored tag moved. Yeah, actually, I did not elaborate on this one, but here we actually have a disconnected second tree. I started from an independent history. I added another file, and this is totally unrelated to the rest. But we could just merge it. Let's just do that one. Refusing to merge unrelated histories.
Yeah, so that's what I thought would happen. I was curious if there was something else that would happen. Because essentially what happens here is that since these two are separated, I think that wouldn't that imply that they have some diff, they have some changes, but then they can't merge directly, or you can't apply these changes directly to, because that branch doesn't have the same history. But yeah, I was very curious.
I just actually confirmed. And so now actually the history is actually merged. So we actually have this main, which is now actually a descendant of nearly all
Oh, wow.
the changes in here. And I can also just to actually clean up my history. We know that this add second is already in here. It's actually here. So we already integrated this one. But just to clean up my history, I can just merge this one as well. And now we can actually see that all the history is integrated into this final main commit.
And when you say integrated, you mean that it has branched off at some point, maybe, but then also it comes back into the main branch.
Yeah, now it's also visually clear that all the changes have been integrated into this one, even though actually this one is actually in twice. But Git just figured out that actually this is just independent history of the same change. And it just did not raise a conflict here.
So it shows as a so when we cherry picked that, all of the file changes, all the diff is in the tree already, or it's
Yes.
in main already, but then
Yes.
the merge is only just a confirmation of the fact that it was merged, not necessarily reapplying those changes.
Yes, exactly. This is just to actually indicate that the history includes this change as well, or this side branch. And of course, this is something we probably don't want to do on Veloren.
Yes.
Because it would just confuse. But this is basically a lot of the things you can actually do with Git, and this is really nice to actually have. And of course, I would like to actually show the safety net within Git, which is actually the. Let me check whether I find the right one. No, this is Veloren history. I probably just need to open it again. So just showing the ref log.
And are you showing a different screen? Because we'll only see TortoiseGit for now.
Oh yeah, okay. That's yeah. I probably actually need to change a different window.
All good, no worries.
So share.
And I'm not sure if it's part of the plan for today, but it would be really cool to open the Git, the Veloren project in TortoiseGit and kind of see what that looks like as well. Okay, cool.
That was a large window I just opened, but since I'm no longer sharing actually the screen, but just the window. That was so. Let's see the ref log. I believe this one is the right one. Yeah, this looks good. So this is actually the ref log. So basically a log of all the references which have been in my local working directory. And even if I just rebased or actually deleted a branch or whatever, if I just messed up, I would still be able to just take the hash from here, and I can just see when it actually happened. So this is the history of my working directory. And I can just show, actually, let's say 2 minutes ago, this was the state of my working directory. And I could just go back here or just create a tag here and inspect what I've been doing. So even if I just moved the branches around in a way which was not what I intended, I can go back.
So when I'm looking at this, in the past, if I'm on a branch and I want to go back, say 5 commits, then I would do head tilde, or not tilde, but whatever the squiggly line is, and then like type in a number. And then that would bring me back a certain amount of commits. But then I see in here we have the @ symbol. And so does this represent, instead of it being on the branch that I'm on, this is just anything in history whatsoever since I've had this project cloned?
This is just your local history of the working directory, and it's not related to the history of your branch you're working on. So even if you just delete a branch, this would still be in this history.
I see. And this history is, so it's only saved in the local directory that I have. So if I reclone or if I delete my folder, it's gone. But is there any other backup strategy for this?
No.
Okay, other than like adding a tag to each one and
Yes.
committing it somehow. Okay, interesting.
Anything which has a name and which you push to the server is saved or preserved. But anything without a name would probably vanish after some weeks. Typically, there is Git has also a defragmentation. This is called Git GC or garbage collection, and this will actually take care of removing all the disconnected parts of your history, which is still in here right now. But if I just cleaned up history, some of these actually might go. or no longer be accessible. So let me just share the screen again and open the Veloren history. So let's just go there. This one is nice. So just actually taking a look at the Veloren history. Show a log. Let's just make this a bit larger. And I will just, let's see. It's probably too small to read, so I will just change the sharing again.
Sounds good. Yeah, so right off the bat, I see a lot more colors in there.
Yeah.
On the branches.
So, individual window. It should be that one. So, let's just scroll to the top. There is actually a commit by Isse. Within the use primitive transform branch. There's a center item drops branch. So there's all these different branches you can actually see here. And you can also see, if you scroll down, see exactly where these branches originate. So a lot of them originate from the current master, which is now stable for, I believe 2 days. You can also see the history of this master, and there is some older side branches. For example, Floppy Cliff Town or Desert City, Weapon Trails. These have not been rebased to the current master. So they are actually still on at a older history. And of course, the more I actually go back in history, the more parallel branches I actually need to visualize it. And there's some parts where actually a lot of side branches actually branch off, and sometimes they just merge.
Yeah, I was curious about this. And so what this would imply is that someone might have merged in a feature, and then other people might be interested to start working on something based on this. And so they'll all branch off at that point so that they can start working with this base.
You can also start a new branch from here. This is weather. So if I actually want to actually develop a new feature which is dependent on weather, I would just start from here. Of course, it all then actually depends on things which you cannot control within Git. Actually, whether Isse would actually include my changes in his branch as well, or whether we would actually work into separate branches and whether we would share history, ongoing history or not. This is all just organizational. This is not within, there's no technical solution to that one. So I just need to communicate to him. So, yeah. We're not that complicated history, actually. I've seen much worse things, of course. With a lot of feature branches, crisscross merging, and having actually a stable parallel development or multiple parallel stable developments. Then you get a lot of rebases, merges, or cherry picks and all these things. And it's quite difficult to just actually maintain an overview of what is merged and what is not. And here is 0.12. Just a bit down to the bottom.
Yeah, so this is like an interesting one because it's a sort of one or there was a branch that was made and then it was immediately merged back in. And so what we can see here is like there was one commit that was made, changed the version number to 0.12. Yeah. And so it was made at a certain time, and like there's like the commit on the master branch after and right before it, but there's nothing else that really conflicts with it. And so, but then on the other hand, we can also see that after 0.12 was merged, then we had a release party. Then we opened up the code freeze, which meant that people could start working on their own features, which is why we have a lot of different branches coming off right after that.
Yes. And there might be older ones, underwater caves, for example, which are not yet on 0.12.
Yeah, and so we can see, like, as an example, there's some branches that kind of have a lot of commits, but then they don't merge back in. So that would imply that there's either still be worked on, or maybe they were just for testing or something like that.
Exactly. There's also the merge. Actually, there's also the commit messages in here, and there is actually the changes. And I could just double click on this one, and now I just need to get that one moved over here. Okay, it's not. Yeah, it's just showing that one.
Yeah, I'll just show the one screen. Unfortunately, not an easy way to swap between them.
Yep.
But presumably, so when you look at these files, presumably, like TortoiseGit has a way of seeing them, but then also you'd be able to open them up in some type of other text editor as well, I presume.
Yes, of course. I can just. Yeah, there's actually just to. You can just save it from here. Save revision to another file, and or just open with. For example, Notepad++ should be in here somewhere. Okay, it's not in here. Let's just need to. Yeah, okay. Server busy. Okay.
Interesting.
No idea which server they actually connected to. But nevertheless, I just got that one opened right here. So yeah, that was actually what I wanted to show about this very interesting tool. Oh, I did not show one thing. Let me just share actually my screen again. And now I will just create a new file and just commit it. Or let's just, yeah. So if we just commit, it will open this really nice dialog. We can actually see all the non-versioned files in here, and we can just select which version, which changes we actually want to include in there. And then we just type in the message and make the commit. And actually this graphical feedback about the changes you're about to commit is most helpful.
Yeah, and so by seeing it, like the commits in a visual way like this, and being able to select the files that you want and select them, choose a message, and I suppose there's probably other options. So we can see here, show unversioned files. Interesting.
Yeah.
Oh, you can set the author even. That's cool.
Sorry, I just wanted to. So I'm just pushing it from here, and I would like to go back to the. Yeah, this was one I was looking for to show. This is actually KDiff3, and this is my favorite diff viewer. And you can probably also zoom in if you actually figure out which key to press.
And so with when we're like looking at diffs, what we're looking at is the lines that have either been added or removed between two files. And so, for example, right here, we can see that when xmac changed a changelog here,
Yep.
he went and added these new lines and then added like a 0.12 version number to the like the previous stuff.
Yes, exactly.
Yeah, I'm curious what this would look like if it was so what oftentimes when you have code that you're changing, you'll have a lot of lines that are added and removed and changed and shifted a little bit. And so, for example, on GitHub, you see that whenever there's a diff, it's that one line was removed and one line was added if a line was changed. But yeah, sometimes I think there could be extra, like more that's done to show off, like exactly how like lines change and stuff like that.
Actually, it's named kdiff3 for a reason, because it actually can also do a three-way merge and three-way comparison. For that, I actually need a merge. Let me I don't have a file in here which actually has interesting enough changes that I would actually see a three-way merge. But actually, if you actually have a merge which had a conflict, for example, you would actually directly be able to see the two changes on the two branches independently within that tool, apply it on the base, which is the common ancestor of these two, and you could just rearrange it, either being the left one or the right one, actually the top one or the bottom one. And also, if you later view that one, actually, if you actually take a look at this merge node from kdiff3, you can actually get a three-way difference.
I see. Yeah. So normally how I resolve stuff like this in like, let's say VS Code is that I'll have like the current changes on the top and then the proposed changes on the bottom. And so this is what I see if I'm doing a rebase and there's a merge conflict, or I'm just handling any type of other merge conflict. And this is all right because I can sort of select what's going on. But then I guess if you have two windows where you can just see the old version, just see the new version, and just see the base, then it could be a lot easier to combine all three of them together.
Actually, if you actually have common history, a two-way merge, it's just it's just nearly unreadable, because you actually have a lot of you basically have two files, and you can either select A or B, and you have no idea which part is actually was deleted on A or added on B. And this is what actually this three-way merge gives you. You can actually see that something got actually deleted on the left side or got added on the right side, and it's actually you can see it differently.
Interesting. Yeah, I haven't thought about that very much, but I should definitely look into if there's like a way to do this in VS Code easily as like a replacement for the current context. Yeah, interesting.
This typically only actually occurs at merges, and so it's probably not that. It might be helpful with actually merging the changelog file.
Yes. Yeah, so and for context on that, one of the sort of issues that we have with the changelog file is that it can be difficult for people to know that when they're adding a feature, if they add something to the changelog, then someone else who is also adding a new feature at that same time will also be adding something to the changelog, and those are like there's a very high chance that they'll conflict, and so yeah, like a way around that. Yeah.
So any questions on the chat, or
not too much, I think.
Okay.
Yeah, I'm definitely down for like I kind of just like give commentary and stuff. I like thinking about some of these kind of things. I think for myself, the biggest thing that I've taken from this is like actually understanding what Git reflog does, and kind of because every single time I use Git, I think of it in like this highly abstracted way where a commit is just the files that I've changed and stuff like that, and I can think of it like this. But then when we were talking today about how everything is always just a hash, and then we have pointers to that hash, then that makes a lot more sense when you're thinking of capacities of what a branch is, what a remote is, or what a remote cares about, what a tag cares about, what all of this stuff is.
I just realized that I wanted to show something. This is actually the interactive Git cheat sheet. So you can just, well, we talked about the workspace, which is basically your directory. We talked about the local repository. This was basically the green and red labels. And there is also upstream repository, which was actually the rose-colored labels. And here you can actually see which command within Git actually moves information from, for example, upstream to workspace. This is pull. This is basically a combination of fetch and merge. So there should also be a fetch, which I don't see right now for some reason.
Another one I don't see is push. And so from your workspace to the upstream.
Ah, no, of course. Of course. This is actually local repository to upstream repository. So
this makes more
here
sense.
is push and fetch.
Oh, this is really cool. I thought if just the first one was all right, it's like, okay, this is a cool visualization, but this is really, really cool. So the idea is like, if I'm working within my local repository and stuff that has already been committed and stuff like that, then how can I get stuff to the stash? How can I get stuff to the upstream? This is what happens if you click on upstream? Or like, sorry, right here. Okay, so this is basically what we've seen already.
Yeah.
Wow.
Sort of. Actually, it's upstream only interacts with your local repository and with your workspace, or so your working directory. Clone creates a workspace, and pull just updates the workspace.
Yes.
And just for the record, stash is about just putting away some changes locally for a short time. And the index is basically the sort of staging understanding. So you can actually already add files to the index, basically by doing add. And then this contents of that file are already remembered. So you can already actually do a diff compared to the index, compared to the last changes you actually added. So it's a sort of lightweight local repository.
Yeah, this is an awesome visualization.
Yeah, it takes a bit from the sheer complexity of all the different options you have. So start fresh. Okay. I actually also have prepared a second half of the presentation, which is about the economy. Should we just do a quick pause, or?
Yeah, we could do like a brief intermission here. And so I think there's a few things I want to add to the addendum here that I forgot to do at the beginning. So first off, Christoph is the economic sims developer for Veloren. And so Christoph focuses a lot on economy simulation. But then also the other thing I forgot to mention was that Christoph has a lot of experience with Git and a lot of like the background stuff. And so can you just, before we end like the Git section, just tell us a little bit about your history in working with version control and on version control systems?
Yeah. Actually, what feels like an age ago, I exchanged actually tarballs or zip files of source code with other developers, and this is of course not scalable. Then we just started using CVS, which is concurrent versioning system, which is luckily extinct or close to extinct today. This had a central server, but actually compared to RCS, which is a predecessor, it was already actually permitted concurrent development on files. I was, actually most difficult thing about CVS is actually that you can not exchange or easily exchange data between servers. This is really complicated. And so I was looking for a better replacement, and roughly around actually the 2003 or so, as far as I recall, there was a development of a new version system, which was called Mercury, also dates back to these times and is still in use. That one was called Monotone, which is actually the name comes from a very ancient idea of actually having continuous integration. So actually this monotonely advancing your history. So actually this one had already some cryptographical signing of working states of the history. So you only you can subscribe only to working parts. This is why it's called monotone. And this was not fast enough for Linux. So when Linux towards roughly 17 years ago actually took a look at monotone for replacement to BitKeeper, as far as I recall, he found that it was not scalable enough. And that is why he took most of the ideas from monotone and just wrote Git, and the rest is history. So you can actually say I've worked on the predecessor of Git.
And then
not a core developer, just doing the CVS to monotone, bidirectional synchronization.
Yes, and so this is super cool stuff. Zester mentions monotone was developed by Graydon, the original Rust dev, right?
Yes, that's true.
Yeah, so that's super cool that you were part of like the history for how this stuff. So for me, like when I started code in university, this is 2015, so all of this has already been around for a while, and so it's super cool to hear the like how you were involved with the past of it.
Yeah, some of the past is actually nice if you just do not think too closely, but I don't want to turn on old computers just for the melancholy reasons, because they are just too slow to do any meaningful things with them.
Yeah. Yeah, so that's super cool stuff. And so monotone, that what era was that? Was that like around 2005 or?
Yes.
Okay, yeah, so about then. And then when was Git first developed?
It should be roughly around 2005, and monotone was probably started 5 years earlier. I actually need to dig into history to just get find it.
Mm-hmm. Yes. Yeah, it's definitely a cool past that I haven't heard too much of.
Yeah, there's also some predecessors to GitLab.
Yes.
Which I have been using in that time.
Okay, like in like the open source form, or?
Yes, that was called Berlioz.
I see.
It was operated by, I believe, actually Fraunhofer. So and it was state funded and dedicated towards bringing open source forward. And actually, when they shut down Berlioz, they did a backup of all the repositories into GitHub. And that's why I was actually able to find some of these things which I did on that platform.
Nice. Another one from Hannibal. Nice wallpaper. Very cool. We'd love to see it.
Yeah, you should actually, apart from the TortoiseGit, no response. You should probably recognize actually the scenery.
Yes.
Okay, yeah.
All right, so I think we're good to get started on the economics sim section.
Yeah, let me just check whether that is actually a top level dialogue or whether I can just override it. Let's see. Yeah, looks we are fine. So
All right.
just going to the second part. Oh yeah, actually there is some links in here. There's this interactive cheat sheet, and there's also a link to the Git internals, which actually explains what a tree is, what a blob is, and all these commands which I used to look in there. So yeah, I would like to introduce you to the economic simulation within Veloren. And what you are currently looking at is roughly at least the third generation of economic simulations, and it's not the latest one, the one in master. It's actually started with a simulation written by Zesterer, I believe, more than 2 years ago. And then it got moved into a different place and rearranged, and that's why I actually started overhauling the economic simulation. Basically, economic simulation is just about this cycle. This is actually the loop which is within the code. So you collect resources, including resources you actually get from trading. You, depending on your needs and your current supplies and your current stock, you actually assign a value to each of these goods, which actually defines which ones are the most needed ones. And this is how you actually reassign professions. So how many people actually should do cooking or whatever. Then the next step is actually to consuming the so after planning how many people actually should do, for example, blacksmithing this round. You consume the raw material from the stock. You produce, which is typically what actually happens during one economic cycle, and just add it to the stock. For trade, it's actually more complicated because it's a two-step, or actually a three-step solution. And the last one is actually to adapt in the population according to actually the amount of food you have. And this is what actually gives the economy a stable state. Any economy will not work without wear or without death, because otherwise you just end up in infinity with all the resources. So you need actually some way of just removing resources and goods from the system just to enter a stable state. And this is the major difference between the economic simulation and the game right now. So this is a list of the common variables within the economic code. Population is the most important one, because all the labor assignments are actually calculated as a fraction of the population. There is stock, which is the current amount of goods within, which are within the simulation of one city. Then there is demand and supply, and these values, which are actually just 2 to the power of supply divided by, I just need to take a closer look, but it's 2 to the power of a ratio between supply and demand. Then there's labor values, which is basically the effort which was actually went into creating a specific good. There's labors, which is the ratio of the professions to the population. And there is productivity, because you don't want to increase professions which have no access to raw materials, even when actually you have high demand for the goods they provide. But you don't want to increase actually the amount of blacksmiths if there's actually no ore within your city. Even if you actually highly need weapons or armor. Because just adding more people to the process will not do any good. You actually need to have more people mining the raw material here. So let's go for a very trivial example. There is raw materials are actually resources. This is the R. And there's so the yellow boxes are goods, which actually get consumed or produced. And there is professions. L, M, and N is the profession, and G, H, and I is actually the good, and R is the raw materials, which actually enter the cycle. And there is some ratio to it. So actually from one half a raw material unit, you can actually, this L profession will create an H, or 1.4 H. And the M profession is actually more efficient. It actually creates 1.5 I. But you actually have to combine one H and I for N. Actually, this N, which is typically the cooking profession, to create actually this G, which is now used by everybody. This is basically the food generated. And if I just run this one, this is an Excel sheet, just running this simulation. Here you can actually see the ratios which actually can change. There is a population, starting population of 100. There is an initial stock of G, H, and I. There is initial values assigned to these. And there is initial productivity. And there is a current labor assignment. And here you can actually see the curve of the availability of the goods. I just need to scroll a bit to the right to get the legend. Yeah, okay. It's not that simple. Yeah. So here you can actually see the result of the economic simulation. So it all starts with actually not having such a good idea about which goods to produce and in which amount. So it basically consumes the initial, it just consumes the initial goods which are in stock. And then at some point in time, it will just stabilize on the, and here you can actually see that there's a lot of more G involved than actually H and I. And there's also the population over time, and it will just grow to a specific point where actually this is the maximum amount of people actually this raw materials which are provided by the environment are actually sustained. So roughly 292 is actually the limit here of the population. So this is actually a very, very simplified variant. So it's just 3 professions and 3 goods. And of course, within Veloren, we do have a lot more questions actually up to here.
One thing I'm curious about looking at the sort of graph that we saw is that so it balances itself out over time. And so is this sort of like an example of like it doing like machine learning to figure out what the ideal balance is?
No, not at all. It's all math. Basically, from actually the amount from population times the current assignment, actually the assignment of labors. This is this labors ratios, which start at 1. You actually calculate the demand for all the specific goods. You also calculate the supply from the previous cycle. Then you actually end up with some surplus or marginal surplus, which is basically the stock plus supply minus demand. You actually end up at a value. And this value is the one which actually qualifies which profession to increase and decrease.
But isn't that also like a very like or the reason I call it machine learning is because it's like changing stuff based on mathematical like values that it tries to even out what something is. And so sure, it's not like the fancy like a whole bunch of like big fancy stuff, but isn't this like a small example? Or like, because as far as I know, machine learning is just like statistical changes over time to arrive at some, well, I guess you're looking for like a maximum or something like that. But I see it stabilizing, and yeah.
Actually, yes. It's similar to machine learning, and actually that it uses matrices. It also uses matrix inversion to actually determine the change of the system, the desired change of the system. And it also uses, or it can use a quadratic error to actually determine how to actually adapt the system better.
Interesting.
So it's very similar to machine learning, but it's not using any neurons.
Well, but I think so the distinction between machine learning and neural networks is that, so neural networks are neurons. Machine learning is just statistical changes. But that being said, I know very little about it. But it's still super. So I think, I don't know if I've seen that graph before, but I love that like it goes like up a little bit and then down, and then like it evens out at one place. And then what I'm sort of wondering is like, let's say like at iteration 17 or something, we become stable, and we can see that we're pretty stable across the line. So one thing I'm wondering, first of all, is when we put this into world generation, but like before the game starts, are we already at a stable point? And then second of all, what might be some changes to some of the numbers here that could make massive erratic changes in the economics very easily?
Let's, for example, just increase this number.
Oh, that's so. Another thing I didn't figure out was that I thought this was data that was exported from Veloren. I didn't know. So I mean, I didn't put two and two together and figure out that this is like just, this is how we take a look at economies and stuff. This is so cool. Wow.
Yeah, this is so. This is actually a live sheet.
Yeah.
I used this one to debug Veloren.
Really?
Because it actually uses the same computations. You can actually see the term there over there. It also has the same name of the variables, like the Veloren code. So I used it to debug why actually specific things happen.
Oh, that's neat. And so let's say, for example, you develop something in Veloren, and then you see these like really erratic behaviors at the level of like, you go up to like a villager and see that something's worth like a ton of money or something like that. Then are you able to sort of take the state and then put that in here and then see what might have caused that?
Sort of. I know perfectly well what actually happens for this erratic prices, and unfortunately, it's not an error of the system. It's the design of the system which is broken. And this is why I'm actually working on getting the changes on the economic rework branch on into mainline. So basically, this is if we take the professions which are actually within. Let me just open the professions within Veloren. You can actually see. Actually, here is. Here's somebody called a banker. This one does not take your stock and just put it to a place where you can actually retrieve it from. This one will just mint coins. So don't be actually misled by the name of banker. We don't have bankers in Veloren yet, or not in the sense of actually storing your equipment. Here you actually see which products they generate.
And so
this is their economic setup.
Mm-hmm.
And unfortunately, there's somewhere in here, I believe actually there is some, it's no longer in. At some point in time, there was actually an overflow of ingredients. And that's why actually some of these, so actually they got produced combined with the fact that Veloren cities right now are only limited by food and not by habitation, for example, or actually living space, they might grow to actually really ridiculous numbers. So 2 million or whatever.
Yeah.
And if actually, because these 2 million people actually are assigned to professions in a way which is also not just actually to enter a stable state, not actually to avoid overproduction. Sometimes actually the ingredients just get overproduced. And this is what leads to totally low prices for ingredients. I believe actually ingredients is most susceptible to this one. And since a lot of things are actually mapped to ingredients, yeah, it just economic feels wrong.
All right. And so I think one thing I do want to mention, time-wise, are you good to go for like another 20-ish minutes?
Let me just check. Yes, 20 minutes is not
20 minutes.
Yeah.
So I want to ask some more questions, and they might be bigger ones. So first off, I'll start with one from Zester here. Could you talk a little bit about how you see the transition between economic resources and the actual item prices working long term?
Wow. Yeah. Let me just continue with my presentation. Actually, there's not that much.
For sure.
Because I have some outlook in there, and it's probably better to start from there.
All right.
So let's see.
This is a very exciting topic. I can talk about a lot of it.
So current active development. This is what's in the EconSim rework branch. Actually, I'm currently working on gathering resources for a specific chunk, actually, because all these chunks are basically assigned to a specific city. So the city actually draws the resources from access to chunks. And for each chunk, you can actually use the scatter and loot tables to reason about the amount of resources that chunk will actually produce in-game. And using that for the economy, actually, of course, is much more beneficial than just guessing some numbers and using them. There's also more accurate recipes because the prices are very, very, I made a simplification when actually computing the prices from recipes. And this simplification is not that good. And I'm currently this simplification is actually basically that for a specific item, there's only one good, so one economy unit equivalent. But if you, for example, create, let's say, a leather armor, you actually need leather, you need some ores to actually generate the sewing set and all these things. So actually within that leather armor, there's more than just armor being modeled. It also contains animal parts and all these things. And this is what I'm trying to put in there. I'm also have implemented non-consumed goods. So basically, there's some tools which might wear, because if they don't wear, you actually end up in a non-stable economic state. There's equivalences. For example, if you are actually living in an icy environment, you will probably not base your economy on wood. You will probably base it on animal parts, and you can create food and tools and fuel from these, and even houses. Currently, the system also has overproduction. Since I used quadratic error, actually a minimization of quadratic error, the overproduction just got stopped. It's just due to a simplification in the current system. And I would actually like to use trade via assignment. So actually using the same logic which is used for assigning to professions, to assign to the trade with neighboring. So future development, distance and effort is currently not taken into account. You can also not see the people working. The simulation is not done at server runtime, but it's just at server startup, and there's also no persistence. And if we actually go for the far future, there's war and factions and site placement according to Economies resources. So it's now getting back to Rester's question about how I would actually see a connection between the resources and actually the prices. There is for sure a connection between economic wealth and actually use of specific goods from the resources provided by the environment. This does not lead to a price. Actually, getting a price is actually sort of an exchange value. It's actually rather more complicated because you should actually assign a value to a good, which you might actually be able to sell to someone who might be able to sell it to someone who has actually some use for it. So there might be some indirections which still add a value and which is very difficult to model using the current system. I have no good idea how to do that, but I just understood more of the problems here. So prices should actually be more, and not only right now they are actually driven by supply and demand, but that's not all of it. Typically, it's also about future demand and some understanding of what's going on there. So some psychology involved with pricing as well. And it would be nice to actually model that one as well. I don't know whether I actually answered Zester's question reasonably.
I'm taking a look at some other ones here. So then Zester also mentioned, of course, price and resource value are different. Translation, not transition. And then there's this last part here. Perhaps sites need some sort of perception of how neighbors value things on average.
They do. This is part of the trade system, which I did not present here. Actually, the trade system is modeled in the way that at the start of each economic cycle, this is actually this need and supply actually decide together with the idea of the prices, actually the exchange rates of last economic cycles are actually taken into account for planning trade. So basically, the information you got during the last economic cycle about which goods had been in extra at a neighboring site and which you actually and which exchange rate you actually got at that point in time are used to plan the trade. So basically, the merchants, virtual merchants, set out from your town with a specific amount of goods in their backpack. They go to the other city. They just trade and also compete with other traders from other cities across, actually on the resources they want actually to buy. And so they will actually come back with a different idea of prices within that city.
So it's up to each agent to have their own information about what they understand the value to be.
It's not right now. It's not about the agent, but this is information, global information within the city. So each city actually has some information about the economic values of the neighboring cities within the last cycle.
Ah, interesting. And so I think one thing that this seems to me is that every city can get to a very balanced state where it knows values of stuff around it. But then what I'd be curious about is what happens when one resource that maybe one city relies on from another city suddenly has no more supply. And so what might this look like?
Typically, just your population rate drops. Because actually it goes into downward spiral. You're lacking access to some central resources to produce food. Right now, food is actually the one determining the population. So you actually end up with a shortage on food. Then during your next cycle, you might actually end up with even less raw materials, and it might actually easily spiral down to actually nearly extinction of a city if it does not have access to the necessary resources.
Okay.
And I've seen that many times within the economic simulation. So if I'm just actually expressing how to actually get food and how to get into weapons and how to actually the hunter depend on how many weapons actually a hunter needs and how many potions a hunter needs to actually hunt for animals, for example, which then actually get into food. Then easily just all the towns just end up with nearly zero in population.
I see. Okay. And so, and then sort of like transitions to the next part. Would you mind going back to the RON file that describes all of the professions?
Yeah.
And so you describe this idea how like we have a lot of professions that exist, but we might not see them occurring in the world yet. And so the reason for this, I assume, is just because, for example, we don't have some type of agent that can represent a lumberjack that might go into the woods and chop down trees and bring trees back.
Exactly. Right now, we do have actually this economic information, which is hopefully in here. Let me just check. So this is actually the representation of the economy. So there is already this labors. This is actually the amount of individuals actually performing a specific profession.
Mm-hmm.
And so this is already in, but it's not used.
Could
be used.
Now,
and then, of course, you would actually need to figure out where exactly actually the resource would be available in world. And you would actually need to move that agent towards that location.
Yeah.
And extract that resource and go back. And so it's actually it's quite a lot of work to do.
Yes. And so when I've seen this in other games, we see it from maybe like an abstracted point where it will say you have 10 workers, 5 of them are skilled workers, and you can put these skilled workers on some of the maybe more bureaucratic jobs or maybe more specialized jobs, and then the other workers have to be just other laborers. Whereas in this case, what we were saying is like, not only do we have to care about whether maybe someone can fulfill the role of what they have to do, but they have to go out and within the simulation of the physics of the world and the like length of time it takes to get somewhere, maybe a lumberjack will go out, chop down the tree and bring it back to the village, and this has to play into the simulation in some way.
Yeah, actually, to really make it visible and reasonable within a world, you would actually take for example, 20 lumberjacks for a specific village and send them out to actually the most rich chunks, which actually contain trees.
Mm-hmm.
You would need to define actually a tree growing rate.
Yeah.
And all these things. So it's actually there's yeah, I did not tell actually what is the current issue with the current economic rework. Yeah, basically I just changed it too much, and now I just ended up with nearly all the towns being empty.
Oh, all the population ran out?
Yeah, exactly.
I see.
And this is actually why I'm trying to actually get it more into a stepwise inclusion into mainline.
I see. Interesting. And so I think when a system gets this complex, then you start having to build a full system that that allows for renewable resources in certain ways. So for example, what I would think is like, if a place needs food, then for them to be able to get food, they can either purchase it from other villages, and to do that they have to have some type of capital, or they could have farms around the village. And so a village might be, because they see their population rising, then they would be incentivized to go and make more farms and maybe take more of their workers and turn them into farmers. And so a lot of these systems, it sort of seems that they have to be self-fulfilling. And so it has to, and is this sort of what you're building towards, answering these questions of what the full circle looks like?
Yeah, basically, the economic simulation in master is not that self-fulfilling within areas of the map where there's actually not a good moderate climate representation, basically. So actually within desert areas and within rocky or icy areas, actually it will just starve to death. Even though actually with the equivalences, you could actually use animal dung, for example, for fuel or whatever, or animal fat, and also actually create a sustainable economy there, which is just based on different types of materials.
Mm-hmm.
And this is not currently not simulated by the current system. It only works because there is some trade between the cities, and they actually help each other out. So if actually there is a city which is disconnected, it probably has zero population, unless it's actually in a very mild climate. But within mild climate, it's very likely that it's also well connected.
Mm-hmm. Another point from Zester, a problem we have at the moment with WorldGen, or is that WorldGen forces the town to be populated even when the economy has collapsed, and so this then leads to weird prices and resource-starved merchants. And so this is sort of the idea that if a village was generated in WorldGen far away from somewhere else, then it might not be as well represented in the economy simulation.
Ideally, you would probably just also simulate actually creating new towns, and so actually just abandoning old towns and just moving to a new place and all these things. So ideally, actually, you would do a similar simulation to the terrain forming for economy as well.
Okay, so yeah, as processed during the initial setup, it would say these are like the current locations of the villages. Will economy simulation allow for them to be sustained? And if it doesn't, then maybe change the positions of the villages?
Yeah, actually, if you during the simulation you actually grow new cities, which might actually start as a camp, and then the camp gets fortified and actually like in real world. So that might actually lead to a different city being abandoned because the resources which had been actually more easily at hand at some point in the past are no longer available, or actually different political factions or whatever. Actually, this is you can simulate a lot.
Yes.
And actually make it a really derive a lot of history and atmosphere from the game from here. But
yeah, there's definitely a lot going on. I will, so since we're approaching the end here, I'll leave it up to you if you want, if there's anything else you want to touch on before we finish off.
Just off the top of my head, not yet, but actually, just as a sort of concluding word, I just I'm working on this economic rework for quite a long time. There had been actually parts in the where I was actually able to provide more time and less time, and I really hope to get it integrated soon, actually by just taking it apart and just I know what to do.
Yeah.
And I don't want to destroy the current economy in the process.
I see. Yes.
So
yeah, that sounds good. All right. Well, I'm definitely excited to see where the economy and the economy simulation will go, and especially I think having talked about some of these topics or what the considerations are is definitely like a lot more exciting to think about some of this stuff. So I do hope that we can have maybe another reading club in the future where we can walk through a new system and see what it does differently and how it interacts with the world.
Yeah.
Great. Thank you so much, Christoph. And we'll see everybody next time.
See you next time. Bye.